Welcome back. Time for chapter 3. We're going to start out with 3-1, graphing and writing inequalities. This is a pretty short, easy section of the textbook, really just reviewing some vocabulary and how to graph those inequalities. You did this last year, so it shouldn't be too much new information here. Your notes, you should be on note page 35, and the first thing you're going to fill in is that vocabulary for an inequality. Right? And an inequality is just saying that two quantities are not equal. And so we use all the, the alligator mouth Pac-Man symbols instead, right? So A is less than B, A is greater than B, A is less than or equal to B, A is greater than or equal to B, and occasionally A is not equal to B, just the equal sign with the slash through it. You don't have to write those things down, just the vocabulary underlined word and its definition. The solution to an inequality is any value that makes it true. And so that means that we have really an infinite number of answers for every inequality because, right, it's going to keep going and going and going. So if I say, x is greater than or equal to 2, then that means everything from 2 on up to positive infinity is a solution. Right? Same thing if I say x is less than 5, everything less than 5, and that starts with 4.9999999 out to, right, as many nines as you can imagine, on down is a solution. So remember, the solutions are not just integers. One way that you can show all of those solutions, because clearly you could not write all of the solutions, is that we use the number line. I know you all love number lines so much. You've just been waiting and waiting to get back to them. But we're going to make them pretty quick and easy this year. I only require that you put 5 numbers on your number line, so you can draw a very short chunk of number line. And on the next slide, I'm going to review how to draw your number lines. You don't have to write that down as long as you remember it. But if you don't, you might want to find some space there or on a separate sheet of paper to write the steps down. Okay, so like I was saying, you don't have to write this down, okay, as long as it triggers enough memory for you to be able to do it accurately. So you're going to draw a number line with at least 5 numbers that are near your solution, and you're not going to forget the arrow tips. So you're going to draw a nice little line, right? Arrow tips on each end. You're going to put 5 little hash marks equally spaced, right, approximately. And then when you number it, make sure your numbering is equally spaced also. Okay. So if my solution, for example, was x is greater than 2, I just put 2 in the middle and I number around that. Okay. Then I mark the solution with a dot on the line at the correct number. So even though the solutions are greater than 2, I still put my dot right there at 2. And I use an open dot for plain less than or greater than. And I use a closed dot for less than or equal to, greater than or equal to. So since this one, my little example here was just plain greater than, I draw an open dot on 2. I know that the solutions don't start until like 2.000000001 at some point, but I still put the dot on 2. And then I draw an arrow starting at the dot and continuing in the direction of the rest of the solution. So since x is greater than 2, I want my arrow to point toward numbers that are greater than 2. Those of you who memorized the nifty shortcut that the direction of the symbol is the direction of the arrow tip, make sure that you don't get confused when your solution ends up being reversed, okay? Because otherwise you'll get a bunch of problems wrong when you have the inequality with the variable on the right instead of the left. So this is in your know it notes. So you're going to want to fill in what's missing there, right? You fill in the algebra and then finish the graph for each of them. We have real numbers less than 5, so x is less than 5. That's an open dot on 5. We're looking at numbers less than 5, so arrow to the left. Real numbers greater than -1. Right, we have an open dot because it's plain less than greater than on the -1. We're looking at numbers greater than -1, so arrow to the right. All real numbers less than or equal to 1/2, and you could count by ones or halves or whatever you wanted as long as you can make a dot there at +1/2. solid dot because it's less than or equal to, and we're looking at numbers smaller than that, so arrow to the left. And for the last one, x is greater than or equal to 0, so greater than or equal means we have a solid dot on 0, and we're looking at things greater than, so arrow to the right. If that went too fast for you, just pause it and finish filling them in. So we're going to try an example here. This is not the example that is on the bottom of your page. You can fill those in also, but go ahead and draw this one off to the right side of the box down there at the bottom of your page. M is greater than 3/4. So I said you have to put at least 5 numbers on your number line. You can count those off however you want though. So you could count in wholes or you could count in fourths. Right? And so to me, it just made sense to do it in fractions. But it would be fine if you did, 0, 1, 2, 3, 4, 5, etc. and put your dot here at 3/4, right? I'm going to put my dot here at 3/4. We're looking for numbers greater than 3/4, so arrow to the right. Okay. Remember, you can always check to see if your arrow is going the correct direction by picking a number underneath your arrow, like 1, and filling it into the inequality. So is 1 greater than or equal to 3/4? Yep, so my arrow must be going the right direction. All right, t is less than 5 times the quantity -1 plus 3. You don't have to write this one down, just watch as I do it. And this is not, right? They're just trying to fool you here, right, into doing a little bit of math, right? And so t is less than 5 times 2, so t is less than 10. So we put our open circle on 10, and we're looking for numbers less than 10, so we draw our arrow to the left. If I want to check this, I usually check with 0, because 0 is so easy. If I plug in 0, it will be less than 10, so I know I'm correct. Now, the other thing you need to be able to do is go the other direction, meaning look at the graph and you write the inequality. Right? So wherever the circle is, that's the number you're going to use in your inequality. You can use any variable you want, and then you just have to decide which direction the arrow is pointing. Right? If the arrow is pointing to the left, then we're looking at numbers less than 2, so we fill that in. It was open dot, so plain less than. On the next one, our number is going to be negative 0.5, and we have our variable, and we're looking at numbers greater than or equal to, because it's a solid dot, and that's it. So that's really all you have to do here, and I think that might even be the last slide. Let me double check. Okay. No more than means less than or equal to. At least means greater than or equal to. So it wasn't the last slide. These are tricky because notice that the words and the symbol are actually opposite. So when I say I want you to make no more than 5 mistakes, that means I want you to make less than or equal to 5 mistakes, right? That's no more than. When I say at least, right, that's going to be greater than or equal to. So I need you to bring at least 36 cookies for the class, right? The number of cookies needs to be greater than or equal to 36. So the wording is a little tricky here. So one last little word problem here, just follow along with. You don't need to write it down. Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees Fahrenheit. Define a variable and write an inequality for the temperatures at which Ray can turn on the air conditioner. So defining the variable is deciding what letter we're going to use, and it's already written down here for us. We're going to use T to represent the temperature, right? And we're looking for it to be at least 85 degrees, right? That means the temperature needs to be 85 or bigger. So T is greater than or equal to 85. Graphing it, solid dot, and arrow pointing toward temperatures greater than 85. And that's it, guys. I think that's like 7 minutes. It's a world's record.